Hello, guys, and welcome back to another episode of Ride Lessons. And this is question 3. And question here is saying it's asking a couple things. It gives us an equation, a differential equation, and this is the population. Our P here stands for population. Now, same thing for the P here. All right, and your dP here, or your dP over dt, will give you the increase or decrease in population over time. All right, so the first part A says, when is population increasing? So if this dP over dt gives us increasing or decreasing over time, that means our dP and dt has to be either positive for increasing, negative for decreasing, or 0 for nothing. And so for A, it says increasing. So when is our dP more than 0? Because if it's more than 0, that means it's positive. If it's positive, it's increasing. And so if we write the equation here, and then we have 1.2p equals, times 1 minus p over 4,200. And so the question here is, when is this increasing? And so when you look at this doesn't really impact our increasing or decreasing. This only impacts our magnitude. Because if our p was a big number or if it was a small number, then it won't change our sign. It won't change it from negative or positive. It will only change the magnitude. And so this is basically nobody cares. And you'll be like, oh, what if p was negative? Well, we have, this is population. Can you have negative rats? Can you have negative people? Can you have half a person? You can't. And so this p cannot be negative because you can't have a negative population. And so we're not really worried about that. And so when we go here, that's why this doesn't change our sign. But the problem is here. So why is the problem here? Because we have 1 minus some fraction. This fraction, depending on the value of p, can either be more than 1 or lower than 1. If it's lower than 1, then this will end up giving us a positive number because 1 minus something lower than 1 is a positive small number. But if you have a bigger number, so here, I'll show you guys an example. So here, this has to be now more than 0, which is, this has to give us a positive number more than 0 for our slope to be positive. And for all values of p, will this give us a positive number? And so if we do 1 minus, let's do some 0. Let's do actually 100 divided by 4,200. And just to give us an exact number, if we do 100 minus 4,200, that's 1 over 42, or 0.02. This will give us 0.02. 1 minus 0.02 is a positive number, which is like 0.98, right? And so this is positive, times it by, if this is also 100, times it by 100 times 1.2 times 0.98, still positive. So if p was 0, so if we go here and we say if p was 0, right, this whole thing becomes 0. 1 minus 0 is still a positive number, but this will be times by 1.2, and if p is 0, this whole thing becomes 0. And you see that it doesn't change our sign, but it changes our magnitude. So if the population is 0, then the population won't increase or decrease. And so what we'll say is, when does it increase? Right? So it can't be 0, so p has to be more than 0 for it to increase, right? P has to be more than 0 for it to increase. And what happens if p was 4,200? Oops, I added an extra 0. This will give us 1. 1 minus 1 is 0. And if this whole term becomes 0, times it by whatever number, this will also give us 0. So that will cause the population to not increase, and it will cause the population to stay in equilibrium. And so what we'll say here is the p has to be lower than 4,200, because if it is 4,200, this will give us 0. It has to be lower than 4,200 for us to have a positive slope. Now, for part B, which is negative, when will we have negative in this? So our dP over dt has to be negative, so it has to be lower than 0. And so our 1.2p, and then we have 1 minus p over 4,200. This whole term has to be lower than 0. Now, if my p, like we said, if p was negative, this will give us, the whole thing will become negative and will give us negative slope, but population can't be negative. And so, again, this does not matter, right? And so what we'll have is, we'll have 1 minus p over 4200. I can fix this for 200. And this whole thing has to be lower than 0. Now, when will this be lower than 0? If p was a bigger number than 4200. So if we do 4500 divided by 4200, so if we do 1 minus 4500 divided by 4200, this will give us 1.07 minus 1. That gives us a negative number. And if this whole thing becomes a negative number, times it by 1.2p, this whole thing becomes negative. And so if p was more than 4200, this will give us a negative number. If p, this is more than 4200, it will give us a negative number, because 1 minus a bigger number is negative. So the answer here is if p is more than 4200. All right. Now for C, it says equilibrium. When is it equilibrium? Now we saw in this equation is that, yeah, I shall rewrite it for clarity. So dp equals dt. In equilibrium, this whole thing becomes 0, because if the slope is 0, it doesn't change, right? And so what we'll say is, again, 1 minus p over 4200. And here we're talking about magnitude. So this part actually matters, because if p was 0, 1.2 times 0 is 0, times whatever this is 0. And so if p equals 0 equals equilibrium. Also, we saw from earlier, if we do, actually no. Oh, so I did miss something quickly. That's what I was thinking about before I ended the video. If p was 4200 as well, so if we plug into this equation 1.2p and we do 1 minus 4200, if we have the same population as this equation, this will turn into 1, right? So we'll have 1.2p equals, that's a horrible bracket, equals 1 minus 1. 1 minus 1 is 0, which 1.2p times 0 is 0. And so also if p equals to 4200, our population will be in equilibrium and it will not increase or decrease.